Hello students, hope you are doing well. In this video, we are looking into the next concept of simple harmonic motion, that is energy in simple harmonic motion. Here we'll see what are the different types of energy that are there in simple harmonic motion, that is kinetic energy and potential energy, and which point which energy is more or less. So let's analyze a simple harmonic motion by taking into consideration a spring mass system. When a spring mass system is at rest, that is spring mass is at mean position, then the energy, there is no energy at all. Now the spring, so the velocity, what is velocity of the spring? Of course, when it is starting, it is 0. Now what I do, I extend it by some amount and release it. So when I'm extending it, this is an extreme position. At extreme position, you can see that we have only potential energy. And we know that, so only potential energy is there in extreme position. Now when it moves towards the mean position, it goes to the mean position. At mean position, we have only kinetic energy. Here I'll have kinetic energy plus potential energy. Similarly, here I'll have again kinetic energy plus potential energy, and again at the maximum compression I'll again have only potential energy. You can see the graph that we have represented. Now this is how the energy distribution is there. Now let's find out what are the various energies. Now first case, I'll find out what is kinetic energy. Kinetic energy it's easier to find what is maximum kinetic energy. Maximum kinetic energy is half m into Vmax. Now maximum velocity Vmax is equal to omega into A, where A is amplitude. So from this I get maximum kinetic energy. Maximum kinetic energy would be equal to half m into omega square A square. Now let's look at maximum potential energy. Now we know that because spring force is a conservative force, there is no loss in energy. The total kinetic energy would be converted into the total potential energy at extreme position. So I can say maximum potential energy is also equal to half m omega square, because at extreme position there is no kinetic energy. So this can be written as half k into A square, because m omega square equal to k, where k is the spring constant. Now this is the maximum potential energy, this is the maximum kinetic energy. So what is total energy? Total energy would be equal to maximum kinetic energy, or that is equal to maximum potential energy. So because when potential energy is maximum, kinetic energy is 0, so total energy equal to maximum potential energy. Similarly, when maximum kinetic energy is maximum, then potential energy is 0, so the total energy equal to maximum kinetic energy. Now in this way, if I draw a graph, I'll get a graph something of this kind. Now let's look at total energy at any other position. If I talk about any other position, let's say the extension of the spring is x. Then what is potential energy? Potential energy for an extension x is given by half kx square. Then what is kinetic energy? Kinetic energy at an extension x can be given as half ka square, that is maximum potential energy, minus half kx square minus potential energy. So I can write this to be half k into a square minus x square. This is kinetic energy at any arbitrary position. So in this way, I can see that potential energy is directly proportional to square of the displacement from mean position, and kinetic energy is this. So if I draw a graph of potential energy and kinetic energy, I get a graph like this. And as we know, total energy is equal to potential energy plus kinetic energy. You will see that at any position, total energy would be equal to half kx square plus half k into a square minus x square. So that will become half kx square. So total energy remains constant throughout. So that the reason, one of the reasons for that is because the forces that are coming into picture are conservative in nature, and if conservative forces act, then the total mechanical energy of a system is conserved. So when you draw a graph for this, we see this. The kinetic energy is minimum at mean position. This is mean position, and potential energy is kinetic energy is maximum at mean position. This is kinetic energy, and potential energy is maximum at extreme position, right? So as kinetic energy increases, potential energy decreases, and vice versa. So the total energy is constant. So this is what is there in SHM. So this is actually energy of SHM. So energy of SHM, what is happening is, what we have seen is, we have got an expression for kinetic energy of SHM, and we have got an expression for potential energy of SHM, and then we saw that total energy, that is kinetic energy plus potential energy, is always constant. And the other thing is like maximum kinetic energy is equal to maximum kinetic and potential energy, which is equal to total energy. Apart from this, one more point that we have to take into consideration while doing questions on energy is what we have discussed now is only energy due to that particular spring. I can have other energies also. What do I mean by that? Now let's say I have, just before saying thank you, I have a spring mass system. Now when the spring is compressed, when the spring is extended, I'll have potential energy due to the spring as well as potential energy due to gravity. So at mean position, I'll have potential energy due to spring is 0, but potential energy due to gravity is not 0. So what I can say is I can confidently say that kinetic energy of a spring mass system is 0 at extreme position, but I cannot confidently say that potential energy of a spring mass system is 0 at mean position. And the reason for that is potential energy might be existing due to other forces. In this particular example, there might be potential energy due to gravity. So potential energy need not be 0 at mean position, but kinetic energy has to be 0 at extreme position. Hope you could follow this. Thank you very much for watching this video, and keep watching other videos of Get My Classes for other conceptual clarity as well as videos on solutions of various types of questions. Thanks a lot for watching Get My Classes.